Okay, so when I say operating system, what's the first thing that pops into your head? Probably Windows, maybe Mac OS, right? But that's really just the tip of the iceberg. Underneath the surface, there's this hidden world of invisible software that's running pretty much everything around us. Today, we're going to dive into these secret operating systems, the code that powers everything from your coffee maker to a global stock exchange. So what do a microwave and a missile have in common? It sounds like the start of a really weird joke, doesn't it? But the answer actually gets to a core principle of all modern technology. Whether it's something totally mundane or something absolutely mission-critical, every complex tool needs a specialized brain. It's all about finding the right OS for the right job.
All right, let's start with the operating system you probably use the most, even if you don't realize it. This is the master of doing one single thing and doing it perfectly, over and over again. We're talking about the embedded OS.
So let's imagine for a second that you're designing a brand new washing machine. You don't need it to check your email or play video games. You just need it to wash clothes. That's its entire purpose in life. The challenge is, how do you build a brain for it that is completely, 100% and permanently dedicated to just that one job?
Well, the solution is an embedded operating system. And the key phrase to remember here is fixed functionality. Unlike your laptop or your phone, you can't just install new apps or uninstall old ones. The OS is built for one purpose from the get-go, and that purpose is locked in forever.
And once you know what you're looking for, you start seeing them absolutely everywhere. Your microwave, your washing machine, even your air conditioner. They're all running on a simple, dedicated brain whose only job is to manage its hardware and do its one thing perfectly.
So this is the crucial point. Its purpose is permanent. You just can't ask your washing machine to start acting like a microwave. Its internal code, its entire reason for being, is fixed from the moment it's manufactured. It is the ultimate specialist.
Okay, so an embedded OS is all about its function. But what happens when the most important thing isn't what a system does, but when it does it? For some jobs, the most critical factor is time. And that's where we enter the world of the real-time OS.
You know, on your computer, if an app freezes for a second, it's annoying. You might roll your eyes, maybe grumble a bit, but what if that 1-second delay could have catastrophic consequences? This is the exact problem that real-time operating systems were invented to solve. A real-time OS, or RTOS, is all about the deadline. The single most important factor isn't the task itself, but when it gets done. In systems like these, a delay isn't just a glitch or a bug, it's a complete system failure. The timing of the result is just as important as the result itself.
But, not all time limits are created equal. These systems really exist on a spectrum. On one end, you have hard real-time systems where there is zero, and I mean zero tolerance for being late. On the other end, you've got soft real-time systems, which can handle a little bit of lag without everything falling apart. And the examples really make the difference crystal clear. Hard real-time is for things like missile guidance systems or flight simulators, where a single millisecond of delay means complete failure. Soft real-time is more for things like online gaming or a YouTube live stream. Yeah, it's super annoying if it lags, but the world doesn't end. Just think about that for a second. For a missile system, if you tell it to do something in exactly 5 seconds, it has to happen in exactly 5 seconds. Because if some other process causes even a tiny little hiccup, a small delay, then, as the quote says, the missile will hit the wrong target. The stakes just don't get any higher than that. Okay, so we've seen systems built for a single task and systems built for a single moment in time. But what happens when the job is just way too big or way too critical for any one computer to handle by itself? Well, then you have to start thinking bigger. This is really the fundamental challenge of the modern internet. How do you build systems that can serve billions of people at once, or perform these gigantic calculations without ever failing? The answer is, you stop trying to rely on just one machine. Now, the solution comes in two main flavors: distributed and clustered systems. Think of a distributed OS like a giant global team of freelancers, like Google's entire network. They're spread out all over the world, each one is independent, but they're all working toward the same goal. A clustered OS, on the other hand, is more like a tight-knit team all working in the same office. They're all connected on a local network, acting together like one single, super powerful computer. And the power you get from clustering is just immense.
You need your service to be online 24/7? No problem. If one machine in the cluster fails, the others just instantly pick up the slack. That's fault tolerance. Is your website getting a huge spike in traffic? You can balance the load across the entire system. And if you need more power down the road, you just add another machine to the cluster. It's built for power, reliability, and growth.
So, as we've seen, from the chip inside your microwave to the servers running a global search engine, there is always a specialized operating system designed specifically for the task at hand. It really all comes down to using the right tool for the job. Let's just recap with a quick little guide. If your problem is a single, fixed task, you need an embedded OS. If timing is everything and delays are not an option, you need a real-time OS. If you've got to connect independent computers all over the globe, that's a job for a distributed OS. And if you need to combine a bunch of machines into one ultra-reliable powerhouse, you're going to build a clustered OS.
The operating systems we've talked about today are the hidden foundation of our modern world, and it leaves us with a really fascinating question to think about. As technology keeps racing forward, giving us things like self-driving cars, smart cities, and even interplanetary networks, what new problems are we going to face? And what new specialized operating systems will we have to invent to solve them?